Slope. We have talked about slope in our earlier slides. Now we wonder what do we mean by slope and what does the particular value of slope tells us. To understand the importance and implication of slope, let's consider the income education relationship that we talked earlier. Suppose that relationship is given by this equation y equal to 5 plus 2x. Y is your income and x is your education level. Now you see that according to the generic linear equation format, 2 is the slope in this equation. So we wonder what does this value of slope imply. So now if you look at this equation carefully, you can see that if you increase the value of x by 1 unit, then the value of y will go up by 2 units. So that's what this slope value is telling us. So the slope basically gives us the rate at which y changes with respect to x. So slope is the rate of change in y with respect to x. Another way to think about the slope is as follows. If you change your education level by delta x amount, where delta, this Greek letter, signifies change in something. So in this case, delta x is the change in x, or in other words, the change in your education level. And as a result, if your income changes by delta y amount, then the slope gives us this ratio of delta y to delta x. So this is another way to think about the slope. So slope can be calculated by the amount of change in your y variable, delta y, divided by the amount of change in your x variable, delta x. Next, we'll be talking about solving for a variable from an equation. Many times we have an equation and would like to solve for one of the variables in terms of the other variables. So that's what we'll be doing in this section. We'll go through a few examples to understand how this is done. In each case, we'll be solving for the x variable. For example, think about this equation, y times square root of x equal to z, and would like to solve for x from this equation. You can do it in several ways. One way can be to first divide both sides by y to get this equation. And remember that we can always express square root of something as that something raised to the exponent of 1/2. So square root of x can be written as x to the exponent of 1/2. So that's what we have done here. Now going from here to the next step, we can do this. We can take squares on both sides. So that will get rid of the exponent of 1/2 from x, and we'll have simply x on the left hand side. And on the right hand side, by squaring, we'll have z squared over y squared. So this completes our solution value for x. Let's look at another example. So this time we have this equation, 10 times x times y raised to the exponent of 1/2 equal to z. And once again, we'd like to solve for x. Okay. First, what we can do is we can take squares on both sides of this equation. That will give us this, right? Then we can divide both sides by 10 squared y. That will complete the solution for x. So x is equal to z squared over 10 squared y. Let's look at one more example before we finish this section. This time we have this equation, 5xy raised to the exponent of 1/3 equal to z, and we would like to solve for x again. First, we can take cube on both sides of this equation. That will give us this equation, 5xy equal to z cubed on the right hand side. Now we can divide both sides of this equation by 5y. That will give us only x on the left hand side, and on the right hand side we'll have z cubed over 5y. So that gives us the solution value for x in this case. The next topic is simultaneous equation system, and how do we solve a simultaneous equation system. So to begin with, we'll first look at an example, a generic look of a two variable, two equation simultaneous equation system. So we have two equation 1 and equation 2, and in each equation we have two variables, variable x and variable y, and a, b, and c, these are parameters of the equations. So when we look at actual equations, these a, b, and c's are replaced by numbers, different numbers. So we have a system of two equations here, and we'd like to solve this equation system for the values of x and y that satisfy equation 1 and equation 2 at the same time. So that's what we mean by solving a simultaneous equation system. Once again, solving a simultaneous equation system means finding out the values of the variables that satisfy all the equations at the same time. So to solve this equation system will mean that finding out a pair of values for x and y, we will denote them by x star and y star, such that when you plug in these two values in equation 1, it will be satisfied, and when you plug them into equation 2 will also be satisfied. The way we solve them is as follows. You can start with either of the two equations, but we'll start with equation number 1, and we'll express one of the two variables in terms of the other variable. So we'll express x as a function of y. So if you take equation 1 and rewrite equation 1 and solve for x, you'll get this following value of x. X equal to c1 over a1 minus b1 over a1 times y. Now we'll substitute this value of x into the second equation. Right, so we started out with equation number 1, solve for the value of x in terms of y, and then substitute this value into the second equation. If you do that, you'll get this. So what we have done is we have taken equation number 2 and we have replaced the value of x that we derived here. Okay, so that's our equation number 2 now. Now notice that in this equation, what we have now achieved is that we have got rid of variable x altogether. There is no variable x in this equation anymore. We only have variable y in this equation. The reason we did this is that now we can simplify and solve for variable y in this from this equation. To do that, what we can do is we can multiply both sides of this equation by a1 and rearrange the equation to obtain this following expression. Okay, so take this equation, multiply both sides by a1 to obtain this equation. Okay, now simplify further and solve for y. You will get this following value of y now. So this is now the solution value of y. So that's why we have put a y star on the left hand side of this equation. Okay, so now we have to find out the solution value for x. Can you tell which is the easiest way to find out the value of x now? The easiest way would be to now take this value of y that we have now derived and go back to this equation where we have already expressed x in terms of y and substitute the value, the solution value of y that we just derived. So that will give us this equation now. X equal to C1 over A1 minus B1 over A1 times the value of y that we derived above. Now if you simplify this further, you get this expression. Okay, so this completes the solution values of x, and it completes the solving of the simultaneous equation system. So we have derived a value of x, this one, and the value of y, this one, that satisfies both equation 1 and equation 2 at the same time. Now we will look at an example to see the application of this method we just learned.